myself, Kalpana, Assistant Professor in Mlritm in EEE department. Today I am going to explain about the electromagnetic fields subject. The topic Coulomb's law and electric field intensity. So in previous class I have discussed about the introduction to electromagnetic fields and also vector analysis basics. So and also coordinate systems also I have explained. Today I am going to explain about the Coulomb's law and electric field intensity. Coulomb's law states that the force acting between the two charges is directly proportional to the product of two charges and inversely proportional to the distance between them. So here, that is F is directly proportional to Q1 Q2 by R square. R is the distance between the two charges. Here we have charge Q1 and charge Q2. It is these two charges are separated by distance R. So here Q1 Q2 is the product of two charges and R is the distance between the two charges. And also this Coulomb's law states that the force depends on the medium in which point charges are located. The effect of medium is introduced in the equation of force as a constant of proportionality. It is denoted as K. So that is F equal to K into Q1 Q2 by R square, where K is the constant proportionality. So this value is given by K equal to 1 by 4 pi epsilon. So here epsilon is the permittivity of the medium in which charges are located. So the units of epsilon are farad per meter. In general, epsilon is expressed as epsilon equal to epsilon naught into epsilon r, where epsilon naught is nothing but a permittivity in free space and epsilon r is the relative permittivity or dielectric constant of the medium with respect to the free space, and epsilon is the absolute permittivity. So for free space or vacuum, relative permittivity epsilon r equal to 1. Hence epsilon equal to epsilon naught into epsilon r, that is when it is a free space epsilon equal to epsilon naught. So force is defined as here 1 by 4 pi epsilon naught into Q1 Q2 by R square. So the value of this permittivity of free space is given by epsilon equal to 8.854 into 10 to the power of minus 12 farad per meter, where K equal to 1 by 4 pi epsilon naught. This value is given by 9 into 10 to the power of 9 meters per farad. Hence, this Coulomb's law is expressed as Q1 Q2 by 4 pi epsilon naught into R square. So here the unit of this epsilon naught is farad per meter. So this is in normal quantity. So when we express this Coulomb's law in vector quantity, we can explain as here. For that I am assuming one origin here at origin, and the two charges are present, point charges are present in the space. So that is Q1 and Q2 with a distance R. So here it is a distance vector. R12 is a distance vector, and these from the origin, this Q1 is at a distance R1 and Q2 is at a distance R2. So here in between these two, it is a distance vector which separates the 2 point charges. Here A12, here I have shown this A12. This A12 is a unit vector. So here to define a Coulomb's law, I am for every charges we have one force, that is on Q1 there is a force F1 and on Q2 there is a force F2. So these are two charges, two forces are oppositely located. Why? Because for in a space, if there is a charge, the charge on the force is it has opposite charge on opposite charge, that is F2. Here force on Q2 is defined as Q1 Q2 by 4 pi epsilon naught into R12 square into A12, where A12 is the unit vector. So it is calculated as vector by magnitude of the vector. So I am defining this Coulomb's law of force in vector quantity. That is the reason I have explaining all these terms. And here and also we have a force on charge Q1, that is F1 equal to Q1 Q2 by 4 pi epsilon naught into R21 square into A21 sorry. Here the unit vector is defined as A21 equal to R1 minus R2 by modulus of R1 minus R2. Here in previous case force on Q2 is given by F2. In there we have unit vector A12. Here these the unit vector on F1 and unit vector on F2 is opposite in the direction. Why? Because the force on Q1 is F1 and it has opposite force on Q2, that is F2. So F1 equal to Q1 Q2 by 4 pi epsilon naught into R21 square into minus A21. We can write it as minus F2. So in a space, if there is a charge, two charges are present. So the force on one charge is and force on other charge are opposite to each other. So that is about the Coulomb's law. Next, concept of this electric field intensity. As we know that, so here I am assuming that one point charge in a space, that is at Q1. So it has positive charge, and again one more charge is present in space, that is Q2 in a distance some R or D. Okay, so here it is a fixed charge and Q1 is a fixed charge and Q2 is moving around the Q1. So there is a force in everywhere, force on everywhere. Why? Because Q2 is moving like this. Okay, so force on F2 is given by, that is force on Q2 is given by Q1 Q2 by 4 pi epsilon naught into R12 square into A12. This is from the Coulomb's law. Thus the force per unit charge, that is F2 by Q2. I am taking that Q2, F2 by Q2, that is equal to Q1 by 4 pi epsilon naught into R12 square into A12. So this is the force exerted per unit charge. So this is called the electric field intensity or electric field strength. And it is a vector quantity and it is directed along the charge Q1 to the position of any charge on the, like this. It is any charge, means this F2 is around this Q1. So this is the concept of electric field intensity. So what is electric field intensity is defined as force per unit charge, that is F by Q. So it is denoted by E equal to Q1 by 4 pi epsilon naught into R1 square into A12. If it is a some position of any charge, P is a position of any charge around the Q1. So in general we can write it as E equal to Q1 by 4 pi epsilon naught into R square into AR. So like this, Q1 and Q2. So the force is directed along this. So that is electric field intensity. It is separated by a distance R. So AR is the unit vector. Okay. So we can write it as definition of electric field intensity E equal to force per unit charge. So units of this electric field intensity is Newton per Coulomb or volt per meter. So we have electric field intensity for different charge distributions will be present. So these are categorized as three types, that is line charge distribution, surface charge distribution, volume charge distribution. Here the charge is continually distributed along the line with line charge density rho L. Then it is called a line charge distribution, that is line charge distribution. So this is a one type of charge distribution. Next, surface charge distribution. If the charge is continuously distributed over a surface, then with the surface charge density rho S, so it is called a surface charge distribution. Next, coming to the volume charge distribution. If the charge is continually distributed over a volume with volume charge density rho V, then it is called volume charge distribution. Let us see the different charge distributions. So it is along the line. We have charges distributed like this. Okay, so it is a line charge. So here the charge Q is defined as integration of rho L into dl. dl is the differential length of this charge, total charge, line charge. Here rho L equal to total charge in Coulomb per total length in meters. So the unit of this rho L is Coulomb per meter. Next, coming to the surface charge. So a sheet of charge I have taken here. So it has charges like this, charges are present like this. So here I am assuming the differential charge here. So total charge is given by Q equal to integral rho S into ds, where rho S is the surface charge density. So the units of this is Coulomb per meter square, where rho S equal to, we can define as total charge in coulombs per total area in square meters. Next, coming to the volume charge distribution, where here I have taken one cylinder like this. So I have given a charge on this cylinder. So, and also I am considering differential volume, that is dV. So in that, total charge is given by Q equal to volume integral of rho V into dV. So dV is the differential volume and rho V equal to total charge in Coulomb per total volume in cubic meters. So these are the various charge distributions in electric field. So next we will derive the equation for electric field intensity due to infinite line charge. So for that I am considering some infinitely long current conductor along the z axis. So it is having line charge density rho L, and this line lies along the z axis. So as we know that z axis has limits as minus infinity to plus infinity, and I am considering one point on this here. I am considering on y axis some point P. So here we have a differential charge here. Here we have a charge. So because of this, at point P, what is the electric field intensity we need to calculate. So here I am considering differential length dl, which is carrying differential charge dq along this line. So this dl, then it is along the z axis, therefore dl equal to dz. So next, so we need to calculate the total charge, total electric field intensity along the line, along the infinite line. So for that I am first considering the differential charge. So that dq, as we know that already we have explained different line charge densities, that is q equal to integral rho L dl. From this we can write as dq equal to rho L into dl. So I have taken this dq from that. So dq equal to rho L into dl. So here I am considering along the z axis, so that dl equal to dz. So dq equal to rho L into dz. So the coordinates of this dq are, so it is along the z axis, so 0, 0, 0, 0, z. While the coordinates of this point means it is located on the y axis. So the point P is 0 and it is y axis, so r. So it is separated by a distance r, that is the reason it is r, and z is, there is no z axis, so 0. Hence the distance vector, we are calculating the distance vector at these 2 points, that is 0, 0, z and 0, r and 0. So the distance vector r can be written as rp minus rz, vector rp minus r dl or dz. So that is given by r into ay minus z into az. So this is the distance vector. So again we need to calculate the unit vector, that is AR equal to vector R by magnitude of the vector, that is vector R is R into AY minus Z into AZ. So we can calculate the unit vector. So after calculating the AR and also we know the DQ, we know that electric field intensity is given by Q by 4 pi epsilon naught into R square. So that is the generalized form of equation. In vector quantity we can define as dE equal to dQ by 4 pi epsilon naught into this distance vector square into unit vector AR. So after substituting all the quantities, we can write it as rho L into dz by 4 pi epsilon naught into square root of R square plus Z square whole square into this AR. AR is the unit vector. So R into AY minus Z into AZ by square root of R square plus Z square. So this is the differential electric field intensity. So we know that for every charge on positive Z axis, there is a equal charge present in the negative axis also. So the component of Z of electric field intensity will be produces such charges at point P will be cancelled at each other. Why? Because here Z and here opposite charge Z, minus Z is present. So these both the charges are cancelled out each other. So hence the equation dE can be written by eliminating the AZ component. So dE equal to rho L into dZ by 4 pi epsilon naught into R square plus Z square whole square into R into AY. Why? Because here the Z component is 0. Why? Because oppositely we have again minus Z term plus Z term. So it will be cancel out. So R into AY by square root of R square plus Z square. So now by integrating dE over A limits, that is Z axis is from minus infinity to plus infinity, we can obtain the total electric field intensity at point P. So E equal to integral minus infinity to plus infinity rho L by 4 pi epsilon naught into R square plus Z square whole power 3 by 2 into R into dZ into AY. So to calculate this, here consider Z equal to R tan theta. So it is from this here. I am assuming theta here. So tan theta equal to Z by R. Okay. So dZ equal to, so R into secant square theta into d theta. So after eliminating the limits, that is Z equal to minus infinity and Z equal to plus infinity, we will get the limits as in theta, that is minus 90 to plus 90. That is the changing of limits. Why? Because I am substituting Z equal to R tan theta. So that I am eliminating this infinity with theta values. So after substituting all the limits and Z equal to R tan theta, we can get here rho L by 4 pi epsilon naught into integral minus pi by 2 to plus pi by 2 R square secant square theta d theta by R cube into 1 plus tan square theta whole power 3 by 2 into AY. Why? Because it is in the direction of AY. So, but we know that here 1 plus tan square theta is nothing but a secant square theta. So, substituting after derivate everything, we will get the E equal to rho L by 2 pi epsilon naught into R into AY volt per meter. So, this is the electric field intensity due to infinite line charge. So, rho L by 2 pi epsilon naught into R into AR. Electric field intensity is expressed as rho L by 2 pi epsilon naught into R into AR. So, R is the perpendicular distance of point P from the line charge and AR is the unit vector in the direction of direction of perpendicular distance of a point P from the line charge. So this is about the electric field intensity due to infinite line of charge. So next, coming to the electric field intensity due to infinite sheet of charge. So for that I am considering one sheet of charge which is having uniform charge density rho s, that is rho s coulomb per meter square, placed in a xy plane. So this is the sheet of charge I am keeping in a xy plane. I am considering in a xy plane. So xy plane is nothing but z equal to 0 plane. So the point P at which electric field intensity I need to calculate. For that I am assuming one differential surface area ds, and it is carrying charge, differential charge dq. So as we know that it is in the along the direction z direction, so that is nothing but r into dr into d phi. dq equal to rho s into ds, that is nothing but r into dr into d phi. So next, substituting electric field intensity, that is dE equal to q by 4 pi epsilon naught into r square into ar. So here dq is nothing but r dr d phi by 4 pi epsilon naught into r square into ar. So and again we need to calculate the distance vector r. So it has two components which is shown in figure like this here. Here we have differential surface area which carries the differential charge dq. So it is at a distance r, and here it is point P is located on z axis in a distance z. So r is the unit distance vector, that is point P to this point. So here this distance vector has two components. So one is along the radial component along the r axis, and that is minus ar, that is nothing but minus r into ar. Next, one more component that is along the z axis, that is az, that is nothing but a into az, z into az. So these two components we can write as r equal to r into minus r into ar plus z into az. Minus ar is nothing but here it is in the opposite side, that is the reason here minus r into ar. So for this distance vector calculated the unit vector, that is unit vector is nothing but vector by magnitude of that vector. So minus r into ar plus z into az by square root of r square plus z square. So after substituting in total electric field intensity, so we know we have a limits phi equal to 0 to pi, 0 to 2 pi, and r varies from 0 to infinity. So here I am substituting the limits here. So we can write it as integral 0 to 2 pi, integral 0 to infinity rho s into r into dr into d phi by 4 pi epsilon naught into r square plus z square whole power 3 by 2 into z into az. So here by to calculate this, to derive this, I am assuming this r square plus z square equal to u square. So and also change the limit, changing the limits here. If r equal to 0, u equal to z, and r equal to infinity, u is also infinity. So after substituting all the limits and integrating, we'll get the electric field intensity due to infinite sheet of charge as rho s by 2 epsilon naught into az, that is volt per meter. So this is electric field intensity due to infinite sheet of charge. So these are the references: William H. Haight, that is Engineering Electromagnetics, Tata McGraw-Hill Education, and Sadiku. These are the reference books, and I have taken this content from the AU Bakshi and VU Bakshi. Thank you.